Hello everyone, myself Hans. Today we are going to solve the given problem based on line integral. Question is given: evaluate the integral, close integral, real of z square dz from integral limit is 0 to 2 plus of 4i along the curve y is equal to x square. Let's solve the problem. Given integral is given by close integral real part of, we have to consider only the real part, z square dz. Integral is given complex quantity and the limit is given by 0 to 4i, 0 to, once again, 0 to 2 plus of 4i, and the curve is given by, and the curve is given y is equal to x square. First we have to draw the figure. Here this is x axis and this is y axis. This is x axis and this is y axis. We have to draw the figure. The curve y is equal to x square is a quadratic, and we have to, the graph of the y is equal to x square is a parabola. So we have to write here, this is the form of y is equal to x square, and we have to consider the point here. This is written in the complex quantity, so we have to consider this is x plus of iy. Here x is equal to 2 and y is equal to 4, so the point is here. This is given by 2 comma of 4, and this is the origin. And further we have to solve. We know that z is in complex quantity, z is equal to x plus of iy, and here we have to find the value of z square. On squaring, this gives z square is equal to x plus of iy ka whole square. On expanding, this gives x square plus of I square into y square plus of 2xy, and here is I. So we have to consider only the real part. Here we know that I square is given by -1, so we have to put here, this is given by z square is equal to x square minus of y square plus of I into 2xy. In the given integral, earlier said we have to consider only the real part of z, and from here z is equal to x plus iy, we have to also include here, this is dz is equal to dx plus of I dy, and the given integral becomes close integral c, and here is real part of z is given by, this is the real part, this is real part, this is imaginary part. We have to consider only real part, so we have to write here x square minus of y square, and in place of dz we have to put in here, this is dx plus of I dy, and further we have to solve. In this gives integral, close integral. Here we can also write this is x square minus of y square into dx and plus of I, and here is x square minus of y square into dy. We have to integrating separately. First we have to let x is equal to t. Then from the curve we get y is equal to t square, and we have to consider the limit or only the real part of limit here. So we have to write here, when x is 0 then t is 0. Once again, here is limit is the limit of t is 0 to 2. We have to consider only the real part of the limit also. and we have to putting here this integral becomes integral limit is 0 to 2, and in place of x we have to let here t, and here is x square, this gives t square, minus of here y square is equal to t square, y is equal to t square is y square, so this becomes t to the power 4, and here is in place of dx we have to put in dt, from here this is dx is equal to dt, and from here we get dy is equal to 2t into dt, and we have to putting here this is the I, integral limit is 0 to 2, and in place of x square we have to put in t square, we have to let here x is equal to t, then x square is t square, and y is equal to t square, then y square is t to the power 4, and in place of dy we have to putting here this is 2t into dt, and further we have to integrate, we get the required result. So we have to integrating first integral, this becomes t square dt on integration, this gives t cube upon 3 minus of here t to the power 4 dt integrating in on integration, this gives t to the 5 upon 5. One second, t to the power of 5 upon 5, and here is integral limit is 0 to 2 plus of I, and here we can also integrating, first we have to multiply it here, this is 2 is taken into outside, and 0 to 2 integral limit is on it, this is t cube minus of t to the power of 5, and this is dt, and further we have to apply the limit in first integral, this becomes, we have to apply in place of t, we have to put in 2 on cube, this gives 8 upon 3, this is 8 upon 3, and here we have to place of t is equal to 2, this gives 2 times of 5, 2 to the 4, 4 to the 8, it was 16, 6 to the 32, this gives minus of 32 upon 5, 2 to the 4 we have to calculate here once again, 2 to the 5 it is 2 into 2 into 2 into 2 into 2, 2 to the 4, 4 to the 8, it was 16, 6 to the 32, and further we have to put in lower limit, we get 0, and further we have to solving another integral here, this gives t cube dt on integration, this gives t to the power 4 upon 4, and minus of here t to the power of 5 dt on integration, this gives t to the power of 6 upon 6, integral limit is here 0 to 2, and here is 2i is already present, and further we have to solving here, this gives, here we have to take LCM, this gives 15, 3 5 are 15, this is 8 4 5 are 40, 5 3 are 15, this gives 32 3 are, this is 6, and this is 96, plus of 2i, and here we have to applying the limit here, this gives on applying of limit t to the power 4, this gives 2 to the 4, 4 to the 8, 8 to the 16, this is 16 upon 4, minus of on we have to putting the upper limit t to the power of 6, this gives 64 upon 6, and we have to applying lower limit, we get the 0, so we have to write here, further we have to solving, this gives 40 minus of 96, this gives minus of 56 upon 15, and here is plus of 2i, and we have to solving here, we are to cancel out the term, 4 4 is 16, and here 2 32 2 is 64, and 2 3 is 6. We have to take in here, taking LCM is 3, and 3 4 is 12, 12 minus of 32, 12 minus of 32. And further we have to solving 32 minus of 12. 32 minus of 12 we get 20. This is 20 upon 3. So we have to write here the final solution is given by minus of 56 upon 15, and here is plus of 2y is already present. Here we have to solving, this gives minus of 20 upon 3, minus of 20 upon 3. This gives, we have to write here the final solution of the given integral. We have to write in here, this is close integral real part of z square dz is given by, here this is minus of 56 upon 15, and here we have to multiplying, this gives 20 to the 40, this is minus of 40 upon 3i. This is the required solution of the given problem. Thank you class, and thank you for watching. The question is based on line integral. UPSC asking 2020 for Indian Forest Service Maths optional paper.